Oh, thank you, Martha. So I see some names here. I think some of you already know me, so we have met before. But for others, I would briefly introduce myself. So I'm Burooj Ghani, and so I'm a researcher at Naturalis, which is a natural history museum, but also a research center where people do all kinds of work on all kinds of scientific questions, including the conservation related questions like monitoring biodiversity and so. So I have a background in computer science model that can do species recognition for orthoptera, grasshoppers, crickets, and some cicadas. So this model is also now publicly available, and currently we are working towards developing similar models for bats and frogs and toads of Europe. So that's very exciting. Um, so the goal of this presentation is to demo the new feature that was recently added to Xeno-canto. I'm gonna introduce Xeno-canto for those who are not already aware of it. So shortly, but the idea is that there's this new feature where you can actually add strong annotations or temporal annotations for recordings. And so yeah, so the idea is to actually go through that and so that we can do it. And I have been really enjoying it. It's been a month or so that this thing is live. But it also makes it very easy now to add labels. And so I have a few slides that I want to show to also motivate the idea of how this can add value for us and why we are lacking it right now. So so just a few slides, and then we can directly go and actually see how to actually add those annotations. So yeah, so deep learning for sound recognition. Well, so I'm gonna be talking about how it will add value from the perspective of creating better deep learning models. But there are also other benefits of, a lot, if you add more annotations or you have strong annotations of your labels on recordings, it can bring value to people who are trying to understand animal communication or animal behavior and so on. But from our perspective, like I said, I'm mostly working towards conservation problems. So yeah, so this is the classical setup of deep learning. So the idea of deep learning is essentially where a model or an algorithm really learns from data itself. So that's the idea. So it learns from data to solve problems for you, for you. And in a classical deep learning setup, you start with audios, and then you convert them into this grid-like representation, which is an spectrogram, and then this black box here, what you see is these different layers of a deep learning model, and that's why it's called deep, because it has many layers, which are essentially mathematical transformations that happen to the data in order for you to solve an optimization problem, and that could be anything. But for us, for instance, if we want to learn a model or create a model for species identification, then your class labels would be different species, right? So then the data is recordings that are on one side, and then the model does these transformation in order to solve this problem, which is essentially mapping those recordings or the sounds from species to which species they essentially are. Now the thing is, like, these are amazing, these models, and they work and they create these representations of the data and then solve this problem. The only bottleneck that I would say is data. Like there are, because we have a lot of advances in good architecture. So there are really good architectures that really efficiently work on data. What I would say one of the biggest problems that, or challenges rather, is still data. If you don't have good data, then your models will also suffer because of that. They will not have a good predictive power, for instance, or they will not generalize well to different situations. So good data is very important, is what is the bottleneck, and that is also what motivates the idea of good annotations. So I'm going to talk a bit about the challenges that we have. Like So now we have these models. I mentioned already that we have the bird model and we have the grasshopper. So what happens when we actually deploy them in the field? So we train them on data that we find on these crowdsourced databases like Xeno-canto, iNaturalist. But what happens when we deploy them in the field? Well, we did this study a few years ago, and we found that on the left side is the data that the model was trained on, like the kind of data that the model was trained on. So this, we call this in signal processing or machine learning lingo, focal recordings. So focal recordings are essentially recordings which you do in a focused way, in a directed way. So you're in front of a species, you see it, you hold your microphone or your phone, direct it to the vocalizing species, and then you record it, right? So this is the kind of data that we generally add to databases like Xeno-canto. But then when you actually, if you want to use sound as a modality to monitor our ecosystems, then what we are talking about are soundscapes. So you basically go out, you strap a recorder to a tree somewhere, and it collects these soundscapes, right? So here, what happens is that you have now, so you have many challenges there, right? There can be many different species vocalizing at the same time. You can have species that are farther apart from the microphone, and so on. And then you have, of course, noise, all kinds of noise. So what we saw is that when we tested it, these models do great on these focal recording, and that's why you see when you're out there with an app. So you have these apps like Merlin and all those. When you will see that when you really direct them to species, they work really well. But when you actually, record data as PAM data, the passive acoustic monitoring data, when you go out and have a recorders recording, then you'll see that these models really, the performance is not as good. And there are many reasons why this happens. There are domain shifts, like your data is from a place where the model wasn't trained on. But there are also other things. I will discuss a few challenges that we have with data that makes it such that the performance really dips when it comes to soundscapes. Similarly, so I came across this article online recently, which essentially says Western AI models fail spectacularly in farms and forests abroad. So this is talking about the same problem that we have. Like the more we train our models on the data, and then even if we go to a different place, then the models, even if the species are the same, sometimes the models do not work. So why is that happening? So I'm motivating the idea of, first of all, we need a lot of data. We need data. We need diversified data. We need data. If a species has been recorded in one place, we still need data from other places. Maybe there are different sounds. The noise profile is different, right? So we do need data from different places. That's one thing. And the second thing that I want to motivate is that we need good data. And good data means well annotated data. So let me talk about a few challenges that will that kind of explain why this is happening. Why are the models failing in different places? Why is the performance decreasing or degrading when it comes to deploying this in field conditions? Well, we know that this is the problem. That's not just with acoustic data, but not limited. It's the problem with biodiversity data in general, that the data has very long tail. So we have common species where which are everywhere, right? And we have a lot of recordings or records for those species, and then we have species which are rare. So then we also have less data for that. And this is a problem that we cannot just simply solve, even if we have all the data. I'm just telling you this to kind of motivate the idea why these deep learning models struggle sometimes, right? And then this creates data sets that are imbalanced, right? So you will have a lot of recordings or a lot of images or a lot of data from some species and not from others. And even if you have all the data from all the species, from all the places in the world, you will still have this kind of distribution, right? Because you have rare species and you have common species. So you can't correct for it in a very simple way. So you have the same problem with Xeno-canto data. So what I showed you here is all GBIF records between 2020 and 2023. So this includes sounds, but also images, observations, and so on in general. So this is the how it looks like. But for then I also went to Xeno-canto. So Xeno-canto is this database of sound recordings, right? Started by two people here in the Netherlands, and so it's a place where people can actually upload their data. It's an open space, so everyone can go and actually critique a recording and say that I don't agree with this. So it's a very open forum, and people can add recordings and yeah. So this was initially, for the longest time, it was limited to bird sounds, but now they have also opened it to some other species groups, including grasshoppers, crickets, bats, land mammals, and frogs and toads, so amphibians. So yeah, you see the same distribution, right? So as if for some species, like here for great tit, you have a lot of recordings, right? For same species, but there are also species for which you have as little as 8 recordings, 5 recordings. So then that's also why we see the models also sometimes, like struggle with those because they haven't been trained with enough data. And then so another problem that we have with biodiversity data is that, so in machine learning, there is this idea of the assumption of identically and independently distributed. So your data should come from the same distribution. It should be sampled from the same distribution, the data that you use to train the model, that you actually then deploy it, right? It should be independently and identically sampled from that. So this is so what you see here on the left side is the true distribution, bird richness around the world. And on the right side, you see all bird sounds in Xeno-canto, and you can see these two almost look anti-correlated, right? So the places where you have the highest richness, you do not have enough data from. So that's the problem. So of course, if you will now train your model on the data that we have, and then you go to these places, even for the common species, it will fail because maybe they have different dialects there, or they have different sounds. So we do need more data. So and I also read in a study that even from places like the global north, where we have the majority of the data, most of the data that exists a 2-kilometer radius from the main roads. So even here, the data is not complete. So we still need more data to really build these models. And then another problem that we have is missing annotations. So in databases like Xeno-canto, where people go out and they see a species, they record it, and then they go home and they upload the sounds. So what the usual way the people upload these recordings is that they have a species that they are hearing, and they go home and they add, for instance, this was a recording uploaded to Xeno-canto, and the person was clearly like recording a short-toed tree creeper, right? So they went home and then they uploaded it, and that's probably the loudest sound in there. But very often what also happens is that while you're recording something, there's also a lot happening in the background, right? There might be a blackbird somewhere very far, or there might be a chiff-chaff. And very often people don't add those annotations. They don't even add even the name of the label of the species, because they were recording something, and that's true for a lot of most of the data on these databases. So if we look at this recording and then we look what actually is happening in this sound clip, you'll see that short-toed tree creeper is just one species in there, but there's also a wren, Eurasian wren, there's a great tit, and there's also a chiff-chaff. So you can see, so now if we take this recording and we train our models on this, obviously the model is gonna probably learn short-toed tree creeper, but it will also basically, so the way these machine learning models work is that what you are going to train it on, it's learning that, and you're essentially telling it that everything else is noise. Everything else needs to be suppressed. So you're essentially suppressing every other sound. So obviously, then, and that's one problem. And the other problem of weakly labeled data is that while you have the label on the whole recording, if you don't know where exactly that sound is in the recording. So if we then train our model on this, we are not saying to the model, we're not guiding it exactly to the point where the sound is. And that's the kind of data we have in these crowdsourced databases. And what we now or have this recent edition project that we did with Xeno-canto, where it now allows annotations in like these strong annotations in Xeno-canto, so which will allow people to actually go to the recordings and add these kind of strong annotations. So that's it. And it's essentially like just this, that we train our models, and we are going to be telling the models exactly these are the clips that you should be training on. This is the real data. So it doesn't lead to any uncertainty in the model about species. It doesn't get mixed signals. Sometimes it gets a species signal, and sometimes there's no label. Then for the model, we are essentially telling it either that that's a short-toed tree creeper, also this shift shaft, or it's noise, you know. So and that's why we have like when people say that, you know, oh, sometimes we really see the species there, but the model doesn't really trigger that species. So it is because most of the model, not most, all models almost out there are trained on Xeno-canto like data, because those are the biggest, you know, like databases out there. So yeah, so now we had been working together and in Xeno-canto. Now if you go to the web page, you'll see they have this article called Annotations in Xeno-canto, and there it really explains so what this meant. Essentially what it meant was that the database structure of this data of Xeno-canto needed to be adapted to allow for strong annotations. And what those strong annotations now look like, once the sound is already annotated and is on Xeno-canto, this is how it will look like. So there will be a these recordings and spectrograms, and then you can actually even open them, and then you can have these different species annotated. So what we will do now is we will annotate one or two recordings, so that we can go through, I can demonstrate the whole process, because for me, it brought me a lot of value. I just have to mention that right now on Xeno-canto, while they have opened it up, but they are still in the phase where they are slowly rolling it out. So it's not immediately open to anyone, whoever has an account on Xeno-canto, but you need to ask them, and that's okay. If you write an email to them, so the article that I showed, if you go to Xeno-canto website, I can also just show you quickly. If I do this, can you still see my browser?
No.
Uh,
No, we cannot see your browser.
Wow,
you need to share the complete screen.
Yeah, it got stuck in the spectrogram.
Okay. Well, I will try this. Yeah, let me know when you can.
Now we can see it.
Yeah, okay, good. So if we open Xeno-canto, so this is how the website of Xeno-canto looks. And if you go down here in featured articles, you can see these two articles, annotations in Xeno-canto and the format. I don't think you need to care too much about this format right now if you follow the process. But if you later have a lot of data and you want to add that data in batch to Xeno-canto, and not by individually adding your recordings, then you would need to convert it into this format, this JSON format. But there's also an article on that on Xeno-canto page, and you can go through it. What I will demonstrate now is how to do this on single recordings. Like if you go out, you record something, you come back, you upload it, and then how do you annotate it immediately? So that's what we are going to do now. But if you want to read more on it, you definitely go through this article that the founders of Xeno-canto wrote, and they really explain it well, that what is the idea of like how does this essentially work. But I want to show you a recording where this has already been done, so that to just kind of explain, to show. So this is how it looks like. Like this is a recording that I made in France, I think, yeah. And then I edited it, and then I added these different annotations. I will play it and
we cannot hear it.
Oh, you cannot hear it. That's a pity. But
Yes.
I'm sure you can go to this recording on your own. But you can see, right? You can see the different annotations, right? That are placed here. So this is how the recording then will look like once the annotations have been done. Of course, it's also a matter of how good you know the species. So it's also possible that you will also miss some. Like I can also see like some things here were probably missed, and a more expert birder might even complete those. But I think anything is better than not having any annotations at all. So then you can at least train your models on these, right? And there's always a possibility that people can then visit these recordings and then add their own annotations to it. So that's also possible. So anyone can add annotations to any recording, and there can be multiple annotations that are assigned to the same some recording, and they will just show up here as annotations, and that's possible. So now what we will do is we will upload. So I want to ask first, like, how many of you here have a Xeno-canto account, and how many of you do actually have uploaded a recording to Xeno-canto? Okay. Yes. I think I know some more people here who have. They're not.
I think Sevi, Hamid, and
Yes,
Sebastian,
yes.
and Antonio must have.
Okay, good. Well, so I think that's a lot of people, so that's nice. Yeah, good. I think most people here, it looks like, have uploaded recordings, but I will go ahead and still upload a recording just for others. So if you have when you open this page, right, you have an account. I'm already logged in, and if you're logged in, that will immediately you can upload the recording. So it will open this page. If you're not logged in, then it will first ask you to log in, and once you log in, you will then be guided to this page, and then you can choose a file. So I am going to add one of these simple recording first, which is a recording of a field cricket I made last month in southern France. And I hope I'm not mistaken, and Luke is here, he'll correct me if this is but I'm very convinced that it's a field cricket, but we'll check. So and then what you do is that you add the location of the place where the recording was done. So I'm gonna just take that from here, because so you just add the location, right, like this, and then you let it search, right, and it will go to that place. You can also zoom in here and actually confirm. Like, for instance, if you think this is not it, then you can also open this, zoom out, zoom in, and find the real place. And then once you know it, you can mark that place, and once you mark it, it will appear here, right? And then it already takes the elevation from an online source, but you can also check if this is correct, but I usually trust it. And then you can I'm just gonna add the recording, although the recording is not from today. I will delete it later. So let's say that we say that it was done today, and it was done at, let's say, 1320. And then you can also select one of these licenses. I think most of them are just basic licenses that like people cannot use for commercial purposes, and but usually it's free, it can be taken and used, so on. And then you can add the recordist's name. So there are fields that are like important, that you have to fill in: name and license and so on. But there are also fields that are optional, and but it's always good to have more metadata, right? You never know what this will be used. Maybe one day someone will want to study the effect of different recorders on different recordings, or the way recordings are made, and or machine learning performance. So then this might be helpful. Similarly for microphone and so on. And then you have this categorization of single species and sound. This is a bit tricky. We already mentioned, right, single species. So single species essentially means that you are, I would understand it as, like, if you go out and you really are focusing on a species and it's the loudest one and you're recording it, then I would go to this single species, even if there are some background species in there, like vocalizing, because it will, on the next page, it will give me an option of adding background species. So you can still use single species. But you can also, for the same recording, you can also use soundscape, because soundscape just means that there is a lot of different sounds in there. So it's up to you. I make this distinction here the way I explained it. If I have one very focal species, which is very let's say where the sound is loud and it's really dominant species in that recording, then I would place it in a single species. But if there, of course, if there's only one species, then I would always use single species, right? In the one that the recording that I uploaded, I would put it in single species, right? So like I did. And then automatic recording just means that whether the recorder was just deployed and you were away and it was recording, and which wasn't the case here because it was a handheld recorder. So I did a manual recording. So I would say no. And then you go to the next page. This is the page. So now it already uploaded it. And now it asks you what is the difference, what is the species. So I will add field cricket. It also allows you to write the scientific name. So it's Cryllus campestris, this one. So this is, at this point, you can also, if you don't know the species, you can also add identity unknown. But then it asks you, okay, at least say which of the groups it is, of species groups it is, right? And then it also will ask you in the end to add a little more detail about where was the recording made. Can you say something about the behavior of the species you saw? Can you say something about the habitat? So this is essentially to later help people figure out the ID of this species. So, but you can also add identity unknown, right? So, but yeah, we know the species here. So it's field cricket. And then that's what we will add. And then there are also some other fields where you can see there's no asterisk, so which means that you can just leave them if you don't know the subspecies, if you don't know the sex, and so on. I would say this is male, but you can also, like, this is something, if you don't know, you can leave it. And animal scene, whether you saw the animal, I did not see it, although it was very close, but this one I didn't see, the one that I was recording, so I'll let no. And then about song type, is the same. It's not a field that you have to. So again, an optional field, but if you know what kind of call it is, like I said, the more metadata you add, the more it makes it rich and can be used for different questions in the future. But yeah, so that's it. And then you go to recording conditions. Again, was it a studio recording? Was it unknown? But it was a field recording, right? We were out there. And then playback, did you use playback? No, we did not use playback. Temperature. So temperature is interesting because, like, for birds, it might not be very important, but we know that for instance, grasshoppers and crickets, they do show variation in their behavior and in their sounds with temperature. So you can add temperature, you can also just leave it out, but maybe this, again, if you add temperature, maybe it can also enhance the data, especially with species groups where temperature has an effect. So I don't remember the temperature, so I'm just going to leave it like that. And like here, you have these background species. This is what I was saying. So if you if the species that you wrote was a dominant species, then you can also, and you know there were also something happening in the background, you can add those here. And you can comma separate it, and then those will also be added to the recording. I will leave it like that. And then quality. So this is also interesting. Quality it's a bit arbitrary, but there is some scale here which you can use it. So yeah, it's in the end it's still going to be arbitrary, because like the first one is loud and clear, and the second one is clear, but the animal is a bit distant. So there are a little bit of a guidance here what you should add. So usually if it's very clear, then I add A, but yeah, so it's up to you. So I'm not gonna go with B here, and then and that's it. And then you add next, and that adds the recording, and then it asks you if everything is correct, and then you go and submit it. So now it says the upload is successful. So if you just open this one in a new tab, you'll see the recording is already added, right? So now what we did is we added a weakly labeled annotation. This is essentially what has been what was allowed, or even if someone wanted to, they could only do this much, which means what we did is that we added that in this recording there is a field cricket somewhere. we don't know where it is, and we also might have missed some background species which we did not add, right? So this is essentially what a weakly labeled annotation means. That now we know it is in there, but we don't know where. So now what you can do immediately is you can go to this software. So you can use different softwares to annotate data, but there is this one software that was also developed alongside when we were adding this functionality to Xeno-canto, and so it makes it very easy. So I use it a lot, and it does. You don't even have to download anything. You can just use it in the browser, and it also allows you to add data directly from Xeno-canto. So like I said, they co-developed it together. Xeno-canto didn't develop it, but the person who developed it, they developed it together to enable annotations, and you can all simply use it in the browser, so you don't have to download anything. So what it asks, what you can do is you can also add a file directly from your computer, but you can also load directly from Xeno-canto. For that, you would need a Xeno-canto ID. So this is the recording that I just downloaded, and this is what Xeno-canto assigned it. I will copy it, and then I will go and I will. So there you see this. It says load from Xeno-canto. So you'll press this, paste it here, you'll do okay, and now it's fetching it. So it fetched it, and this is the recording that we made, right? And you can see that there is like it has only data only until a certain kilohertz here, so which means that we don't probably need this much. So you can also play with it. You can also, like, in order to better visualize it, you can also say that I only want to see until, let's say, what do we have here? I only want to see until 24. Then it kind of hides that, and then you already only see this. You can also play it here. You told me that you don't hear it, but yeah. So you can play it here to know where the sounds are. You can see that these are like the sounds. So then what you do is that you can add the scientific name here, right? Essentially what you do is there are multiple species. You always have to first write the name of the species, and then you do the annotations for them, and then you can go to a different species. I always do that because you can only have one species added here for which you can at a time add annotation. So since I don't know, or like I cannot write the scientific name, so I will go to common name. If you press on this, you can shift to common names, and then it was a field cricket. Field cricket. By the way, I want to quickly ask Luke. Luke, does that make sense? Is it a field cricket?
I can't hear the sound, so
But you can definitely open it in the meantime on your own, because now the recording is uploaded. And if you want to, in the meantime, confirm it, I'm going to paste it here in the chat just for if you want to confirm.
Okay, I'll try and check it. Okay.
So that's the recording. But I will go ahead in the meantime.
Yeah, yes.
Oh, I see David is here. Hi, David. So I'm gonna go back. So now you see, like, right, you can play it. Like I said, you play the recording, plays, and then you can change it to common name here, and then I will add field cricket, and now you see the field cricket is already added here, Crylis campestris, right? And then if you go to the spectrogram again, you see that there is this it allows you to kind of see where you are. So now, obviously, I mean, this is again something that people have different ways of annotating their recordings, right? I usually try to make them as tightly bound as I can. And for instance, you see that this is like the main frequency and the energy, and then there are also these higher harmonics, right? You can see them here. So it is possible that sometimes you lose them, right? Especially when you have even higher frequency sounds, sound making species. And then, but since we see it here, I would include them. So I would usually include them, and because, I mean, if, for instance, when we think from the perspective of deep learning models, it's again, the more data you have, the better. So deep learning models, if you include them, they will also use that information to train this model. So I would use it. Okay, I think, is there a question? says that the call ends in 15 minutes. Okay, so, so we go like this, and then we can like. So usually my rule is, like I said, there are different annotation styles, but my rule is when I annotate, the heuristic I follow is that if between the sound events, if there is more than 1 second, then I will not connect them. If it's less than 1 second, sorry. But since it is not less than 1 second here, it's literally a few milliseconds here. So I will just connect all of this. But you can also do like this, and then you can also use this whole thing as a separate annotation. It's up to you in the end, you know, like because here's nothing happening. So, or you can also just make one annotation. So that's it. Now you added these two. If there are more species, then you could also add them. Then what you do is that you go here on the right side, you click, and then on the low, you can also just save these annotations. Then it saves it into a text file, right? Or you can just go directly down here, and it says Xeno-canto integration, right? And there you can say upload to Xeno-canto directly. So you can press this, and then it already copies the Xeno-canto file number. You can also give it a different, you can also copy that number if it's not there. You can also add your name, who is the set creator. Set is basically a set in which the annotations are placed. And then you do have to add an API key here. And this API key is the key that Xeno-canto assigns to each user. So you will have your key. If you go here, you go to your account, and here you see there is an API key. So just copy it, and then it will already save it. You don't have to copy it each time, but you need this because that's how it connects with it communicates with Xeno-canto. And then your name is automatically there, blah blah blah. And there you can also export it to your computer, and you can also directly upload it to the API, or you can do both. If you press both, then it will also like download a copy of this on your computer. But I did direct upload with API, and then you press proceed, and now it says that it was successfully uploaded. So then you go back. If you go back to your computer, if you open Xeno-canto, you go to your account, and then on this account, like if you do have the access to add annotations, you will see this annotation sets here. So you open it, and then it shows you all the sets that you have uploaded to date. But then there is this one set that you just added, right? Why this? Because this still gives you, like, it needs to first check what you added to see if everything was correct. It needs to verify it, whether all the fields that is required are there or not. So once you did that, so it says that it was successfully parsed and it found annotations there. So then you can do import, and then it imported, and then it adds it to this last place. So we saw that before when we added the recording. Okay, that page is now gone. But we saw that it just had weak annotations. But if you now open it, let's first open this recording. You'll see that this recording, but it also now gives you these annotations here. These are the ones that we added. So if you go here to the spectrogram, you'll see that it's already been added now, like this. So it's as simple as that. And you can similarly do it for multiple species. I wanted to do the same thing with one more recording, but I think it's going to take a long time. So I will just go through one more annotation set here, and then maybe we can open for a few questions so that we don't run out of time. But I did want to have one more difficult recording. But I think it's very clear now. For instance, here, you can see that it's Bonilli's wobbler. And then similarly, this one is not the difficult one. So it was this one, I think. Wait, no. Doing the same thing again. Yeah, for instance, this one. So there was, okay, this is again a grasshopper, a cricket that we found in France, in southern France last month, and earlier this month actually. And you can see that it also, you can make these very tightly bound boxes. But I also have this one recording there where, oh yeah, so this one, for instance, was a recording where I annotated crickets and birds together. So you see that there is this field cricket in the background that is continuously there all throughout the recording, as you can see. So since there was no break, I edited to do a single annotation. And then there's a blackbird, there's a chiffchaff, yeah, there's a blackbird, so on and so forth. And you can also see that sometimes they're also overlapping, and that's fine, because what I'm basically, when I hear where it starts and where it ends, then I just basically annotate that and so on. Yeah, so that's it. That's how you essentially annotate it. So I think I'm going to stop here, and if there are any questions, then we can maybe take those. Thank you.
Well, it was so nice and so interesting. I think all the people have enjoyed this talk, and it's going to be very useful to all of us, because I think you have cleared a lot of doubts that a lot of people have in the TIOS workshops sometimes when uploading, and these kind of things that there is a lot of species. One is more loud, another are less loud, and they are how my data is going to improve the models, no? If it's all together and not classified. I think this integration of Spectrolipi is awesome for the people, and we are going to join to our formations, to our workshops, and I think we can start to work together.
Yes.
And I think all of you, in particular Sevi, Hamid, and Sebastian, and Antonio, have some recordings on Xeno-canto. We can spend a little time trying to make our annotations, and Sylvia soon is going to have, I know.
Well, I can tell you, if it makes sense. I'm not
Yes, there are some.
really know much about sounds, like bird sounds, and I usually work with data, and for me, like I said, I'm a computer scientist, but trust me, I am having such good time like adding these, because if I go out and I see something and I'm like so excited, I'm gonna go home and add these annotations. But many of you are actually experts, right? You know these sounds, so for you it's like we really need your data. So please do this. Please add your data, and it's gonna add so much value. So yeah.
Okay. Now, I don't know if someone have any doubt or wants to do some question.
Yeah.
Hi, David.
First, apologies for being late. I got distracted dealing with something else and it completely slipped my mind. I do apologize. The annotation tool looks amazing, but would it be possible to convert Raven selection table annotations into this new format? Because I've got a stack of about 20,000 of them, like from Spain, from Serbia, Germany, everywhere. And if I have to redo them all, I would cry and be very sad.
No, we don't want to make you sad. So, David, I'm glad you asked this question, because two things. One, Raven is right now actively working. They were also working with us. So the Cornell Lab of Ornithology, who built Raven, they were working with us. So right now they're updating their structure, like their annotation format, the schema that comes out, which will be exactly the same as what Xeno-canto accepts. So, but that is for future, right? So in the future that will happen. So they are creating this Raven workbench right now, right? So there will ultimately happen. But about the data that has already been there, I think the best way would be to write a small adapter script, right? Because there is a format, like I showed this on Xeno-canto website. If you go, there's an article that has the actual schema there, right? The format. So in that, it would mean to map your fields with that. So, but in the end, it will need to be converted. But I don't think this can be done with one script, and I'm sure you can do that. I mean, but feel free to reach out and ask, and we can also do this together. But it's a matter of converting your annotations to that format, and that would just be because there are some fields that are optional, and there are only a few fields that are must. I'm sure those fields you already have. So that is essentially what's going to be who created it, time, start time, end time, lower frequency, upper frequency. That's basically the fields that are the must. And I'm pretty sure that you have those fields if you did strong annotations. So yeah. So.
Absolutely.
Well, it was so nice to have you, and we say you thank you for your time, and thank you for all of you to have came. And well, I hope see you soon in some Theo's workshop or Theo's activities. And well, have a nice grasshopper or birds or bioacoustics day.
Thank you, guys. Thank you for
Good
joining.
evening.
Ciao.
Thanks, Burooj.
Thank you.
Thank
Bye-bye.
you.